Okay, here's a fun question because it shows and reminds us that equivalent fractions are not always just in pairs, right? We can create strings that go on forever and still use all of the relationships we know about proportional or equivalent relationships and fractions to solve these things. So let's look at A right here and try and make a connection. So we look at A, we have 6 over 14 and then 20 something over 21 and something over 28. And we might feel like we did some kind of cross multiplication or reduction here, but I think we should realize that we can reduce 6 over 14 to make this a lot easier. So how do we reduce 6 over 14? Well, I'm just going to take numerator and denominator and divide both of them by 2. And what do I get? Well, 6 divided by 2, that's 3. 14 divided by 2 is 7. And now we see that easy connection, I think, because 7 goes into both 21 and 28. This allows us to quickly scale this up. How many times does 7 go into 21? Well, it goes into it 3 times. So what I would do is multiply this fraction by 3 over 3, right? And that gives me 9 over 21. So our first mystery number here is 9. What about 28? Well, 7 also goes into 28, but it goes into it 4 times. So 7 times 4 is 28, and 3 times 4 is 12. So our second mystery number here is 12. What about B? Well, over here, again, they're doing the same thing with this string, but here with 8 over 36, again, we can reduce that. Divide it by, this time, 4, right? Numerator by 4 and denominator by 4. And 8 divided by 4 is what? Well, it's 2. 9 divided by 4, well, 9 divided by 4 is also, right, working out nicely for us and gives us 9. So now you might see a connection here because the other denominators are 27 and 63. So how many times does 9 go into 27? Well, 9 times 3 is 27. So we multiply denominator by 3 to get 27, and the numerator by 3 to get 6. So here I put a 6. And that's our mystery number there. And 63 also works out nicely now too because 9 goes into 63. How many times does 9 go into 63? Well, it goes into it 7 times, right? So 9 times 7 is 63. And we want to keep this proportional, so we also have 7 groups of 2, right? 2 times 7, that's 14. So in this case, this mystery number is a 14 right there. And we keep going. C and D hopefully should have the same properties. And I'll just write it in here because I realize, oh, 6 over 30. If I divide 6 by 6, I get 1. If I divide 30 by 6, what do I get? Well, 30 divided by 6 is just 5. And now I notice that these denominators are both multiples of 5. So 5 goes into 25 5 times. We also should then scale up 1 5 times to get this numerator, 5. 5 goes into 20 4 times. So we multiply our numerator 1 by 4, and we also get this mystery number, 4. So these two numerators are 4 and 5. Last we have D. So for D, right, this is mixed up a little bit, but we have more than enough to solve it. Because if you notice, 32 and 8, right, are connected. 8 is a factor of 32, right? And, of course, 32 is a multiple of 8. So if I take 32 and I divide it by 4, I get 8. So if I take 24 and I divide that by 4, I should get 6. So I have this fraction already done, 6 over 8. Now 6 doesn't go into 15, but if we reduce this, if we reduce 6 over 8, what do we get? Well, 6 divided by 2 is 3, and 8 divided by 2 is 4. So this is equal to 6/8, right? 3/4, 6/8, those are equal. And that's nice because what happens now is 3 goes into 15. And that's nice, right? Because now we can easily scale this up. 3 times 5 is 15. 4 times 5 is 20. And that's our last mystery number, 20. All right, hope this helped.